Okay. Have you done this experiment before? This one, there's a coin on top of a
No,
cup.
I have not done it.
No. Now, when you give the cup a flick the cup, use your finger, you flick the cup. What happened to the coin? This is like
The coin will drop into the cup.
the coin will drop into the cup, into the glass of the cup. Correct. Now, why is it so? At first, the coin is stationary. The coin is stationary. Because the coin has inertia, it has the tendency to remain stationary. It has the tendency to remain stationary. Although the cup is taken away, removed quickly, you are actually moving the cup. You are not moving the coin. So the coin has inertia. It has the tendency to remain stationary. So this tendency to remain stationary and not follow the cup, not follow the cup. So when the cup is not around, the coin will not move in the direction of the cup, but it will fall vertically downwards because it has inertia. It has the tendency to remain stationary. Okay, now we look at this experiment here. This experiment. Okay, so what have you heard of this experiment before? There is a weight hang by a thread or a string, right? Hang by a string. Now at the bottom there, you tie another string, same material, make of the same material and same thickness at the bottom here.
This experiment, I think I did it before already.
Okay. So when you pull slowly, because the string at the top and the string at the bottom, they are the same size and they are made of the same material. When you pull at the bottom slowly, the the string at the top not only has to support the weight here, it is also fighting against the tension at the bottom there. So the string or the thread at the top is subjected to two forces. The string at the top here is subjected to two forces. The first force is the weight of the force of the weight. That is the mass, the weight of the weight lah. And the second force acting on this string is the pulling force exerted by the hand. So this string has two forces acting on it. So when you pull it down, naturally this one will break first because it has two forces acting on it. Whereas the string at the bottom here, only one force. That force is the force exerted by the hand. The weight is at the top, so the weight doesn't exert any force at the bottom here. The weight only exert a force at the top. So when you look at this string or the thread X has two forces acting on it. The string or the thread Y has only one force acting on it. So when you pull slowly, naturally this one subjected to a greater force, two forces. So this one will break first. This one only one force, so it will not break first. So this is the first part of the experiment. This is the first part of the experiment. Now the second part of the experiment is we are not going to do it this way. We are not going to pull slowly. You are going to pull it quickly at the bottom here. You just give it a jerk like that. You just give it a jerk. So when you jerk the string here, which one will break first? This one will snap first or this one will snap first? X will snap or Y will snap first. Then, to your surprise, although you give this string a jerk, the string at the top didn't break or didn't snap, but the string at the bottom here will break. Why is it so? Why is it in the second case, instead of pulling slowly, you give it a jerk? Why is it that the thread Y will snap first? Do you have any explanation for this?
Um, why thread Y will snap first?
Why snap first in the second case? First case, X will snap first.
You pull. Oh wait. This is because it's stationary. Or is it Y is subjected to the full pulling because Y is subjected to the full pulling force. That's why it snaps first.
The reason is because of the weight here. This weight here. This weight here. This weight here, it is not moving. It is not moving. So it has the tendency to remain at rest. Now, when you give it a jerk, you pull at the bottom there, the force is only, is, how to say, counteract by the inertia of the weight. The inertia of the weight is acting against the string. So as a result, the force, your jerk, the force at the bottom is not transmitted to the string at the top. It is not transmitted to the string at the thread at the top, the thread X at the top there. So the inertia of the weight, the 10 Newton weight, prevent the force from transmitting to the top. Because this one has inertia, when you pull, you are actually fighting against the inertia of the 10 Newton weight. So as a result, the string Y will snap first because you are fighting against the inertia of the 10 Newton weight, the 10 Newton weight. So the string Y will snap. Okay. Have you experienced this one before when you want to
No, I
throw
have not.
the chili sauce?
No.
How you pour out the chili sauce? How you pour you pour try to pour out the chili sauce? Yeah, you give it a jerk. You quickly move down, then you stop and you pull back the bottle, and the chili sauce starts to flow out. But if you try to pour it like that, because of maybe surface tension or the viscosity of the chili sauce, because it's very thick and dry, so it refuse to come out. But if you give it a jerk like that, throw it, then pull out, the thing will come out. Why? When you move the bottle, when you move the bottle downwards, when you move the bottle downwards, not only the bottle moves downward, not only the bottle will move downward, but the chili sauce inside will also move. The chili sauce inside the bottle will also move downward. Okay, right. So when you move the bottle downward, both the bottle and the chili sauce is moving. But suddenly you stop the bottle. You stop the bottle and you only stop the bottle. Can you stop the sauce or not? The source is inside the bottle. You cannot stop the source. So because the source has inertia, it will continue to come down. It will continue to come down. And that is how it gets separated from the bottle and drip out or pour out of the bottle. Okay, now in this case, they tell us that the chili sauce inside the bottle has inertia. It will continue to move down even though the bottle is stopped. You separate the chili and the bottle by means of the inertia of the chili sauce itself. Any questions so far?
No question, sir.
No question. Now, one of the many applications of inertia is what happened inside the safety belt or not? When you go inside the car, you have to put on the belt across your body. Yes. Now, when the car suddenly stop, you feel that the seat belt is pulling you back. Why? Why when the car is not moving or already moving, the seat belt is you can easily pull out the seat belt. But during emergency brake or when the car suddenly stop because it knocked against something, but this seat belt, it will not roll out. It will help to prevent you from moving in front. Now, what is the mechanism behind the seat belt? What is the mechanism behind the seat belt that enable the seat belt to lock itself? The seat belt is locked. So when an accident happens, the seat belt is locked and it will prevent your body from moving forward. But ordinary time, when there's no accident and so on, then you can easily move forward, even though the seat belt is there. What is the reason behind? Oh, there is no sensor, nothing inside, no electronic sensor, nothing, but the seat belt just simply lock when accident happen. Why? This is the example given inside the textbook. It is an application of inertia. You want to read this first? You read this?
Under normal conditions, the ratchet turns freely to allow the harness to wind on or unwind from the pulley as the passenger moves. In an accident, the car undergoes a large acceleration and rapidly comes to rest. Because of its inertia, the large block under the seats continues to slide forward along the tracks. The pin connection between the block and the rod causes the rod to pivot about the center and engage the ratchet wheel. At this point, the ratchet wheel locks in place and the harness no longer winds. Oh,
Yes.
yeah.
Yeah. Actually, there are two stages here. The first stage is this one, the normal state. Let me type out using the word. The normal state. Normal state, okay. Normal state. Now, which one is the normal state? This is the normal state. This one, this position. When the car is moving with constant velocity, or when the car is at rest, the rod under the seat is in a vertical position. In a vertical position. This is the normal state, right? This one. It is in this position. And it is pivoted at this point here. Pivoted at this point means the rod is free to rotate about this point here. The rod is free to rotate. Now, when an accident happens or when the car is suddenly stopped, okay, the car is actually moving in this direction. The car is actually moving in this direction. Okay, moving in this direction, M. When the car suddenly stopped, the block attached to the rod here will not stop on its own, because you are only stopping the car. In an accident or when you step on the brake, you are actually stopping the car. There is nothing to prevent the inertia of this block to continue moving in front. So during this second stage, when the block continue to move in front because of its inertia, it will pull the rod along. It will pull the rod along. So when it pull the rod along and it is pivoted at this point, the rod will bend, the rod will tilt, sorry. The rod will tilt towards the ratchet. This rod, when the block move in front, it will carry the rod along. So the rod will get tilted. When the rod is tilted, it will block the ratchet here. It goes into the one of the gap inside the ratchet there, and this will prevent the ratchet from rotating. So when it prevent the ratchet from rotating, this seat belt will not loosen. The seat belt will not loosen. The seat belt is locked in that position during the accident or when you step on the brake. This one is the normal state, is the straight one. During accident or brake, it is the tilted state. The rod is at the tilted position. This one is during accident, right? During accident or brake. Okay, when you have accident or when you brake, the block will move in front. Only the car stop. Because of the inertia, the block will move in front. When the block move in front, it will tilt the rod. When you tilt the rod will go into one of this gap along the circumference of the ratchet there. So when it goes inside, it will prevent the ratchet from rotating. So it cannot rotate, that means it will lock the seat belt in that position. So there is no sensor, there's no electricity, there's no electric things inside the car to activate the seat belt. There's nothing there to activate the seat belt except the inertia of this block. The inertia of this block will tilt the rod. When it tilt the rod, it will stop the ratchet from rotating. When you stop the ratchet from rotating, the seat belt cannot move. The seat belt is locked in that position. It will not lengthen anymore. So the principle behind is inertia of the block. Any question?